this video we are going to see a problem on DLS of a cylinder, which is the development of lateral surface. And here is the question. A cylinder of 60 mm diameter and 80 mm long stands with its circular base on HP, a section plane perpendicular to VP and inclined at 60° to HP, cuts the axis at a point 20 mm from its top end. Draw the front view, sectional top view and DLS of the truncated cylinder, that is the cut cylinder. So this is the question in front of us. Now, whenever the cylinder is kept with its circular base on HP, in that case, from the top view we are going to see the circular base. So I'll start with the initial condition here. So we have to draw the circle in the top view and the diameter is 60 mm. So it will be in HP because it is resting in HP. So the circle will be drawn in HP. Radius 30 mm. Now after drawing this circle in the top view, that is in HP, I will divide it into 8 equal parts. We can even divide it into 12 equal parts for more accuracy. So measuring 45° on both the sides in order to divide it into 8 equal parts. Here I'll give the notations. The height of the cylinder is given as 80 mm. So I'll plot it in the front view. (80 mm) height. So I'm measuring 80 mm. Drawing a light horizontal line. Now this is the height of the cylinder. Cylinder looks like a rectangle in the front view. So I have given the notations in the front view as well. Now I have to locate the cutting plane, and for that the condition is given. A section plane perpendicular to VP and inclined at 60° to HP. Inclination with HP will be seen in VP. Cuts the axis at a point 20 mm from its top end. So here this center line shows the axis. I have to take 20 mm from the top end. 20 mm. It means the cutting plane will pass through this point. Inclined at 60° to HP, seen in VP. So inclination can be taken either on any of the sides. I am drawing a light horizontal line here. Measuring 60°. Drawing a light line. Now this light line represents the cutting plane. I'll make this cutting plane dark. This is cutting plane AA dash. Now as an observer, when we are looking from top, then the portion which is closer to the observer should be removed. So if we are removing this much portion, the bottom part has to be retained because we want the sectional top view. So whatever is retained, I'll make that dark. It means this much portion of the cylinder is removed, and whatever I have drawn dark, that much is retained. Next, in the top view, when we are looking here, the cylinder is being cut at this location. So when I project this point in the top view, here I am going to get a line, and that line will be dark, and whatever portion is there onto the left hand side of this line, this much portion will be retained, and this portion is there, and on the other side whatever is there, on that portion there will be sectioning because that portion is cut. So I have to draw 45-degree inclined lines here. So here is the sectional top view. Next, I have to draw the development for this cylinder, and when we are drawing the development of the cylinder, if the cylinder is opened about point 1, then it will be covering the complete distance equal to the circumference. So for a cylinder we are going to get the circumference here. So I'll calculate pi d. Pi into diameter is 60, and this answer comes out to be 188.5, which I can take it as 188 mm. And now I need to plot this 180 mm here. For that, I am drawing a light vertical line first. Now from this point, I'll take the distance equal to 188. So I've taken this distance as 188. Now I have to divide it into 8 parts. So if I divide 188 by 8, that gives me the distance approximate, that is 23.5 mm. So I have to take the distance as 23.5 mm. Taking this distance, I'll divide it into 8 equal parts. So I've divided it into 8 equal parts because I have divided the circle also into same number of parts, drawing parallel vertical lines to these points. Now I'll give the notations here as well. Next, I have to see that which are the points over which the cylinder is being cut by the cutting plane. So if I see here, it is not cutting this generator 1 dash 1 dash, neither it is cutting 2 dash 8 dash, but here I am getting 2 points as I see in the top view. I'll call them as points X and Y. So in the front view, here I am getting the point as X dash Y dash at single location. Now point X is in between 7 and 8. So for that purpose, I'll measure the distance from point 7 up to X and mark it between 7 towards 8. Then drawing a light line through it, light vertical line. Now this line is indicating X double dash generator, and I'll plot this point X will be at the same location if I take it from the front view. So here I'm getting point X. Then similarly for y, I'll take the distance from point 3 to y and mark it from 3 towards 2, and that will give me y double dash y double dash. So here I am getting y double dash at this location. Next, here the cutting plane is cutting generator 3 and 7. Both the generators are being cut at the same location. So here I'll give the notations as a dash comma b dash. So where it is cutting 3 dash 3 dash, I'll say that is point a double dash. Where it is cutting 7 dash, that is giving me b dash. So the same line will be projected light. Where it is cutting 7 double dash 7 double dash, that gives me b double dash. Then where it is cutting 4 and 6, I'll say the points are c dash and d dash, and where it is cutting 4 dash, that will be c dash. So projecting light horizontal line up to 4 double dash, that will give me c double dash. Then on this same line there will be d dash cutting 6 double dash. Then it is cutting 5 dash at this location, which is e dash. So here we have point e double dash. Now I'll join these points in the proper sequence with the help of a French curve. This is the continuation of the problem. So joining the points in proper sequence. Next, I'll make it dark. Next, after joining this, all these points, now y dash and 1 dash are connected. So I'll connect y double dash 1 double dash. Then even x dash is connected to 1 dash. So x double dash 1 double dash will be connected. Then the outline will be made dark. So here is the development of lateral surface for this truncated cylinder. Next, I'll give the dimensions. Diameter is 60 mm and the height of the cylinder was 80 mm given. Then cutting plane is inclined at an angle of 60° to HP, it was given. Then the intersection point was at a distance of 20 mm from the top end. At last, the circumference. So here I am giving the dimension to the circumference, which is pi d, and that is equal to 188. And with all this, we complete the problem.